the rate of change we're going to talk about. Rate of change, we're going to talk about the change in y over the change in x. Now when we talk about rate of change, the rate of change for a line is always constant. There's a constant for a line rate of change happening as we go along the y. As the y changes, the x changes, and it's the same as you go up the line. So we're going to look at these tables to see if these are linear. And so what we have to do is we have to go from point to point and then look overall, is the rate of change the same amongst all of them? So if we look here, going from this point to this, we look at our y's, our change in y's. Let's say we have -8 minus -6. We see how much that changes, and 4 minus 1. So we have -2/3 as our rate of change there. From -10, or this point here, we have -10 minus -8, and 7 minus 4, which then gives us another -2/3. From this point to here, -12 minus -10 over 10 minus 7. That's -2/3. And going from there to there, -14 minus a -12 over 13 minus 10 equals -2/3. So, do we have a constant rate of change? -2/3, -2/3, -2/3, -2/3. Yes, this is linear because it is constant. Let's look over here. If we go from here to here, we take 12 minus 10 over -1 minus -3, and we see that we get 2 over 2, so that's 1. From here to here, we take 16 minus 12 over 1 minus -1, which gives us 4 over 2, which is 2. From here to here, 18 minus 16 over 3 minus 1. That gives us 2 over 1, which is 2. And from here to here, we go 22 minus 18 over 5 minus 3. That gives us 4 over 2, which is 2. Let's see, I made a mistake. This should be 2 over 2, and this being 1. Regardless, we see we have a rate of change of 1, 2, 1, and 2. So this is not linear because it is not constant. All right, another way we can talk about rate of change is if we call it the slope. A slope of a line, we have our change in y's over our change in x, or we can think of it as our rise of a graph over the run, or we can think of it as like our delta y over delta x, and specifically we can think of it as y2 minus y1 over x2 minus x1. And we're going to use that for m, our slope, most often. So if we are given 2 points and we need to find the slope, we're going to use this y2 minus y1 equals x2 minus x1. And these shouldn't be exponents, they should be subscripts. We have y2 minus y1 over x2 minus x1. My bad on that. That's why we use pencil. So let's see, if we assign x1 y1 and x2 y2, and we use this formula to find our slope, we're going to do 5 minus 0, because that's y2 minus y1, over x2 1 minus x1, -2. So we're going to have 5 over 1 minus -2 over 3. That can't be reduced, so there's our slope. If we look at -3, 4 to -3, and we have x1, y1, x2, y2, we have -3 minus 4, y2 minus y1, over 2, x2 minus -3, x2 minus x1, so we'll have -7 over 2 plus 3, that becomes 5. So you have a slope of -5 there. Hopefully this is a review, so we are going to move kind of quick. Let's see if we have x1, y1, x2, y2. Do y2 minus y1, so -1 minus -1 over x2 minus x1, 2 minus negative 3. Negative 1 minus negative 1 becomes negative 1 plus 1, which is 0. Over 2 minus negative 3 is 5. 0 over 5, that's a slope of 0. That's okay, we can have a slope of 0. Now over here we have x1, y1, x2, y2. We're going to take negative 3 minus 4 over negative 2 minus negative 2. And we get negative 7 over negative 2 minus a negative 2 becomes that negative 7 over 0. Now, this negative 7 over 0, we should know we can't have any fraction over 0, so this is what's going to be called undefined slope. And if we think about our slope of a line, if we have a positive slope right here, positive slope, our line is going to be increasing as we go from left to right. A negative slope, the line is going to be decreasing as we go from left to right. If we have zero slope, think of zero slope as it takes zero effort to walk across that line. It takes zero effort whatsoever to walk across that line. Positive slope, you got to put in some effort to climb up a hill. Negative slope, you have to put in no effort. You can just run down that hill. And it all even takes less effort than anything. Zero slope, you're just walking. And if we have an undefined slope, it is impossible to walk up that line if it is undefined, all right? So here's a visual representation of what each of our slopes mean. Remember, slope is y2 minus y1 over x2 minus x1. Now, we could have a situation where we're given the slope and we have to find one of the coordinates that's missing. So we have to find the value of r, so the line passes through each pair of points so that the line passes through each of the points has the given slope. That doesn't really make sense, but you know what I mean. So we're going to use, remember, our slope m equals y2 minus y1 over x2 minus x1. So let's see, x1, y1, x2, y2. So I'm going to take r minus 4 over negative 5 minus 1, which is r minus 4 over negative 6. And I know that this slope equals 1/3. So r minus 4 over negative 6 equals 1 over 3. That's easy. Now what do I know I need to do? I need to do the proportion. So remember, 3 times the group r minus 4 equals negative 6 times 1. So 3r minus 12 is going to equal negative 6. So then I easily add 12. So 3r equals 6. Divide by 3. And r equals 2. So that means that our point is going to be negative 5 comma 2. Let's look over here. If we have negative 2 comma 6, r comma negative 4, and a slope of negative 5. So when we have x1, y1, x2, y2, I'm going to take negative 4 minus 6 over r minus negative 2, which is negative 10 over r plus 2. And that's equal to negative 5, which I'm going to write that as negative 5 over 1. And again, I'm going to do the cross product, so negative 10 times 1 equals negative 5 times the group r plus 2. So I have negative 10 equals negative 5r minus 10. I'm going to add 10 to both sides to get all my constant to one side and have 0 equals negative 5r. I'm going to divide both sides by negative 5 and see that r equals 0, so the point over here would be 0, negative 4. Alright, let's take a look at these practice problems. We are on page 471, 15 through 39, multiples of 3. So, this first one, 15, find the rate of change represented in each table or graph. So we have an XY table with the X values being 1, 2, 3, 4, and the Y values being negative 15, that's positive 15, 9, 3, and negative 3. So we're going to find the rate of change. We're going to assume that these are lines. We're going to assume that they're lines. So let's see. I'm going to use these 2 points. So remember, I'm going to do my change of y's, which means I'm going to go from 3 minus 9 over 3 minus 2, because that's my y minus my x's, We get negative 6 over 1, which means my rate of change is negative 6. Have fun. Ask questions tomorrow if you need help.